Hello, everyone. Welcome to GitLab Commit. I hope you're getting out of it everything that you were expecting so far. My name is Senegal. I'm from Red Hat. I'm a solution architect that's part of the Global Partner Alliances organization. I'm here to show you a demo of GitLab and OpenShift together. But before we get started with the demo, let me talk to you a little bit about the partnership. Well, why does GitLab and Red Hat make sense? Digital transformation is calling for more and more workloads to become cloud native. As these workloads transform, so are the processes that are needed to develop, build, and deploy them. Together, GitLab and OpenShift form a perfect platform for developing and deploying these workloads. For those of you who don't know, Red Hat OpenShift is a hybrid cloud Kubernetes platform. Well, what does that mean? Simply means OpenShift is not just another Kubernetes distro. It is 100% Kubernetes, but it's a lot more. It contains features such as developer services with code-ready workspaces, a service mesh, cluster management services such as logging and monitoring. On top of all of this, OpenShift runs across any infrastructure an enterprise is using, whether it is physical, virtual, public clouds, or private clouds. This gives enterprises the greatest flexibility and security as they move workloads to the cloud. You are here at GitLab Commit, so it's obvious that you are aware of GitLab's value. They provide a comprehensive platform that meets the needs of DevOps teams delivering solutions to the cloud. The features that stand out the most to us at Red Hat is the optimized Kubernetes deployment. This is one of the things that you'll get to see today in the demo. Well, what is it that we do together? First of all, together we are building a bridge between traditional application development to cloud native application development. GitLab, of course, supports both traditional app development as well as DevOps. OpenShift provides the tooling and infrastructure to not only develop cloud native apps, but also to build, deploy, execute, and manage them. For starters, what are we doing? For starters, we've built a GitLab Runner Operator. Well, what does that mean? We know today that there's a variety of ways to install a runner into a Kubernetes cluster. That's nothing new. This operator is a new install method that allows DevOps teams to deploy a runner while inside an OpenShift cluster. What's more important about this runner operator, though, is that it lays the groundwork for automated operations of the runner, such as auto updates for new releases, auto recovery, self-healing, etc. We're also in the process of building an operator that will bring these same capabilities to the GitLab server. Well, you might ask, what is an operator? And for those of you who don't know, I'll give you just a little bit about an operator. An operator is essentially an automation tool to automate all the manual steps required for day one and day two operations for a Kubernetes application. In this case, our GitLab Runner is that application. An operator has a maturity model that spans from a simple install all the way to self-healing. During this demo, you'll see the GitLab Runner Operator in action. But now the GitLab Runner Operator is only responsible for deployment of runners, but there's potential for this operator to grow in maturity over time. Well, let me tell you about exactly what you'll see in the demo. You'll see in the demo the installation of the GitLab Runner Operator, the creation of a runner object and instance, a peek into the OpenShift code-ready workspaces, a CI/CD pipeline running in GitLab. You'll also get to see the runner execute those pipeline jobs. And hopefully the application that I've created as a demo will work. Well, let's get into the demo. Okay, for the demo, we'll start here in the OpenShift console. And you'll see I'm in the administrator view. OpenShift also has a developer view. But in the administrator view, you'll see the cluster. And in the administrator, you are allowed to manage all of the resources that exist in a Kubernetes cluster. In our case, what we're interested in is installing the GitLab Runner Operator. So we start here with the Operator Hub. The Operator Hub is essentially a marketplace of operators. These operators are responsible for all of the operations regarding the applications that they manage. Here you can select by different categories, or you can filter by a particular name. We have over 100 operators, over 100 different partners that we're working with to build these operators, and this number just grows over time. For our purposes, we'll search on GitLab, and you'll see GitLab operator shows up directly in any OpenShift cluster deployment. And what you'll see is, here's the operator page that describes the operator, what it does, where's the repository. As you'll see, the capability of an operator is described here. In our case, the runner operator that we have here is only a basic install at this point. But as I said, they have its potential to grow into all of these other phases as needed. So I'll simply go here. I've chosen the right project, and I'll install this operator. It has several different options. We'll just take these defaults. And you'll see now that our operator is getting deployed and installed. And now it is installed. So let's go on to the next step. So now that we have an operator, if you see here in our operator, it describes exactly how the operator is used and what you have to do. One of the first things you have to do before you create a runner instance in the OpenShift, you have to create a secret. This secret requires a token from GitLab. And this token allows GitLab and the runner to communicate securely. So what we'll do is we'll go into our GitLab instance, we'll go to settings, we'll go to CI/CD, we'll go to runners, we'll expand the runners, and we'll basically just grab this token. So once this token is grabbed, we can go back into OpenShift now, and we can create a secret. The secret we're going to create here is just a simple key value secret. The name of this secret, as you can see, if I already created one, was runner token secret. The key is runner registration token, and I'll just paste in the value that I copied from GitLab. At this point, our secret is created, and now we can go back into installed operators. We can go into GitLab, and now we can go and create our runner. You see there's no runners created at this point. So now we'll go on and create our runner. I'll give it a name of GitLab, typo here, GitLab commit runner. We're going to connect to our GitLab instance, and we're going to use this as our token to communicate with GitLab. So now let's go proceed and create our runner. So now you see GitLab commit runner. It's initializing. In a few minutes, it'll be created. All right, we see that our GitLab runner is now created. And so now we have a connection between this OpenShift cluster and our GitLab instance. All right, so now that the runner's in place, let's take a look at our project. We'll actually go through a real exercise of creating a change in our project. So I have a simple project here that has a simple Node.js application that displays something to the screen. It has a browser. So what we'll do here is you've seen the files here. And now I'll show you a little bit about code-ready workspaces. If you look at this, if you notice, you'll see that I've pulled in this project from GitLab, done a clone of it. And so now I have my project files all here. One of the things that's part of GitLab is this CI/CD pipeline. So as part of this process of making changes, we're going to commit a change from this IDE, and that change is going to be pushed into the GitLab repo. And from that change, that's going to initiate this pipeline to get created. In this pipeline, you'll see a typical OpenShift pipeline that goes from development to staging and production. In our cases, we just have 3 stages: build, package, and deploy. So we'll be done with that rather quickly. This is code-ready workspaces. This is a development environment built into OpenShift that's available to OpenShift users, developers. This is a cloud-based IDE. I have no reliance on anything within my own laptop or in some hardware that I have packaged under my desk. Everything that I need for the development of application is within an OpenShift cluster that I can manage and have access to from any browser. So let me make a quick change in here so that we can see this all in action. So I'll say I want to change this from GitLab commit express to express demo. Let's now make this change. You'll see that an M comes here, which means this file has been modified. So let's go to our source code control, which is Git. And we'll do is stage these changes. Okay, so now the changes are staged. We'll go on now to commit those changes. In order to commit those changes, we'll have to give it a message. And we'll just say added demo. Okay, so now those changes are committed, but now we need to push this into our repo. So now we'll push them into our repo, which requires us to log on to the repo. And then we'll have to enter a password that I will copy and paste in here. Okay, so now we're connected to our repo. You see our changes have now been pushed up to the GitLab server. We can go to the server and look at our file, and we'll see that demo is now added to this file. All right. In addition to that, now that we've committed those changes, we can now go look at our pipelines. And what you'll notice is that we have a pipeline that is running. So here we're in the prepare phase of this pipeline. This is the job that's running. And what we're doing in this prepare phase is essentially creating all of the objects that we need to execute this. So you'll see that we're logging on. This is all output from the runner. We're logging on to OpenShift inside the OpenShift cluster, and we're applying all of the elements. So we're creating a build config, deployment config, image stream, route, and service. So all of this is happening as part of this runner job. Okay, next phase is build. So now we're in the process of executing the build within the OpenShift environment. This build is going to take a second or so. Okay, our build job has now completed. There are other parts of this job, and we have package also. So the package part is complete. So we look at the output, where essentially we are now pushing this new image that has been created into the registry. That's the package part of the process. And there's a deploy part of the process. And let's take a look at that. So what's happening now is we are logging on again, changing to the right project, and we're executing a rollout of our deployment configuration. So essentially, from the GitLab perspective, this particular pipeline is complete. Each one of these steps were completed through the runner execution of commands within OpenShift. The check means that they're all successful from an OpenShift, from a GitLab perspective, and everything should be ready in the OpenShift environment. So let's have a look at our objects that have been created in our dev environment. So let's see what we have here. You can see that we have our test, We have our test pod that's running a minute ago. We have our deployment config. So let's take a look from a developer perspective. We can go into the project. We have our application here from a previous run. We have our deployment config. But as you can see, our application now is started up and available. The pod is ready. We have our route that's been executed. And so now we should be able to go in and open up this application and see the results of our changes. And now you see it. GitLab Express demo, and the application has been updated. That completes our demo for the day. Thank you for listening in and paying attention to what we're doing between GitLab and OpenShift. I'll be around if you have any questions, and look for us to be doing a lot more in terms of this partnership. Thank you, and continue to enjoy GitLab Commit.